In this video, let's learn how to calculate heart rate from an ECG strip. So whenever we talk about heart rate, we always talk about lead 2 because lead 2 is known as the rhythm strip. So over here in the upper segment, we have a heart tracing or ECG tracing. From that, we will try to find out the heart rate. Now heart rate is basically beats per minute. Now one beat is equal to ventricular contraction or ventricular depolarization, I can say, which is represented by an R wave. So each R wave over here represents one heartbeat. Now we have to calculate how many beats are there in 1 minute or 60 seconds duration. Now for that we will talk about the RR interval. Now suppose between any two R waves over here, that is this R wave and this R wave, we have X number of small boxes. Now we all remember the holy grail of ECG, that is one small box is equal to 0.04 second, one large box is equal to 5 small box equals to 0.2 seconds. This is the basic learning we have to remember always. Now we can say that one R wave comes after every X small box. That means one R wave comes after every X into 0.04 second. Or we can reverse this and can say that 0.04 X seconds contain one R wave, 1 second contains 1 by 0.04 X R waves. That means 60 seconds, which is 1 minute by the way, will contain 60 by 0.04 X R waves, which is nothing but 1500 by X R waves. That means in 60 seconds there will be 1500 by X beats, and hence heart rate will be 1500 divided by number of small boxes. And as one large box is equal to 5 small boxes, it will be 300 divided by number of large boxes. So this is the holy grail formula of our heart rate that we have achieved by now. Okay. Now based on this calculation or formula that we have derived, let us try and determine the heart rate of the upper ECG. Now in the upper ECG between two R waves, that is this one and this one, let us see how many small boxes are there. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 R waves. Alright. So the heart rate will be basically 1500 divided by 16 small boxes that we determined, which will be equal to 93.7 or 93 beats approximately. Right? Now this is valid when we have a regular rate. Like over here, if you see, all the R waves are coming after almost around 3 large boxes, almost around 3 large box, almost around 3 large box, almost around 3 large box. But if there is an arrhythmia, what will be the case? Let us see now. In the lower strip, if you see, the RR wave variability is huge. Like in the first RR wave variability, that is around 3 large boxes. But over here, the RR wave variability is around 5 large boxes. Again over here, it is around 4 large boxes. That means the rhythm is irregular or arrhythmic. So in case of irregular waves, we cannot apply our 1500 by small box formula. This could not be used in case of this. For that, what we do, we calculate a 10-second duration. So what will be a 10-second duration? 0.2 second is equal to one large box, So 10 second will be 10 by 0.2 second or 0.2 large box. That is 50 large box. So we will be calculating 50 large boxes. Now we will calculate how many R waves in 50 large boxes, that is 10 seconds. Suppose we get X number of R waves. So 10 seconds contains X R waves or X beats. So 60 seconds will have 6X number of R waves, and that will be the heart rate. Suppose in 10 second duration, that is 50 large box, we get 12 R waves. So the heart rate will be 12 into 6, that is 72 beats per minute. So for regular rhythm, we have the 1500 by small box formula, but for irregular rhythm, we have the 10 second rule. So you have to remember the 10 second rule.